12:30 for some other people. So hi, thanks again, Janae, for the introduction. My name is Kaylin Henderson, and I'm a staff scientist at the NASA Exoplanet Archive. So this is one of the many projects run by the NASA Exoplanet Science Institute, or NExSci, at IPAC at Caltech. Here, I'm going to give you an overview of the various data, tools, and services that we offer at the NASA Exoplanet Archive. And I'll note that these are freely available to both professional astronomers and the general public as well. So in particular today, I'm going to go ahead and highlight some new products that we're in the process of releasing as part of a large-scale long-term revamp. So let me go ahead and share screen. All right, hopefully everybody can see the homepage of the NASA Exoplanet Archive. So before I really jump into describing everything, I'm going to go ahead and chat in the Zoom chat a YouTube link. Where's the chat? There it is. To everybody, this is a recording basically of this webinar presentation. I'm going to try to do a live demo now, but just in case I get disconnected, or if you want to pause on anything specific that I've said, you can go there and check it out. And I know that the WS is also going to provide a recording of this specific version, I think with a 24-hour turnaround. So to get started, this is the home page or the front page of the NASA Exoplanet Archive. I'm also going to go ahead and include this link in the chat. But if you just go to your preferred search engine and type in NASA Exoplanet Archive, or even just Exoplanet Archive, even Bing should be able to find this page, so that should work. There's a bunch of different types of interfaces here. So I'll begin with our primary data products, which are our planet data tables. Those of you who have used our services before are likely familiar with our confirmed planets table. Over the next few months, however, we will fully phase out this table as part of our aforementioned revamp process, and we encourage all users to instead begin using its replacement, our new planetary systems table. So we've pinned a description of this transition process to our first news item. So there's number 1 here. If you go ahead and click on that graphic, this takes you to a documentation page that will help you walk through our table migration, and that provides descriptions of our new tables and how to access them. So let's go back to the home page. One of the ways that you can access this new planetary systems table is by clicking on this button in the top left that gives the current tally of confirmed exoplanets. And this will take you to an interactive version of the planetary systems table. So in contrast to the confirmed planets table, which contains exactly 1 row for confirmed planet, the planetary systems table contains 1 row for each solution or self-consistent parameter set for each planet. So as you can see down here at the bottom, this means that whereas there are 4,324 confirmed planets, there are actually nearly 30,000 rows in this planetary systems table. When you first load the table, it's filtered to show only the default parameter set. That's this column right here. And this is to say that you will see only the solution set that has the most complete and precise set of parameters from the refereed literature. So let's go ahead and remove this filter. You can interact with this table using all of these boxes here, and I'll do this a little bit later on as well. And let's look at all of the solutions for a sample planet. So I'm going to pick Kepler 10b and just type it directly into the planet name here. So here we can see that there are several different types of solutions. So I'm looking at the solution type column here. And this includes many from the refereed literature. That's identified by the solution type published confirm, as well as Kepler project deliveries, which includes solutions from when this object's disposition was merely a planet candidate. So you can see Kepler project candidate. And then over here in planetary parameter reference for the literature solutions, you actually get a link to the ADS paper manuscript. And for the Kepler ones, it tells you which quarters of data were used, and you can access the KOI table. So if we continue scrolling to the right, past the solution type, we can see that there's a bunch of different parameters for the planet. So here we're seeing things such as orbital period, planet radius, eccentricity. There are also data columns for the stellar parameters, so effective temperature, metallicity ratio. And if we keep going, there are also parameters for the system, planetary system as a whole. So these are things such as coordinates, magnitudes, and proper motions and distances as well. And at the very end, you can see that there are columns referring to date of ingestion or updates by the archive staff. So that's helpful for us internally, but we figured it might be helpful for y'all as well, so we've included it there. I'll note, before I scroll all the way back over, that the underlying catalog for our database is version 8 of the test input catalog, or TIC. So you can see that many of the stellar parameter references and virtually all of the system parameter references are going to point to TIC v8. So let's scroll back all the way over to the left. By default, only a subset of data columns are shown, and so you can select and deselect these as you see fit using our column controls panel up here in the top left. So if you click on select columns, you can see that there's a bunch of different columns, and they're grouped by different categories: names, systems composition, discovery information, detection methods, and then planet parameters, stellar parameters, and system parameters. And then only a subset of these are checked by default. So you can interact with and manipulate those as you see fit. So let's go ahead and actually do that. So I'm going to drag, actually, but click and hold the orbital period column all the way over to the left. You can just do that with any column as you see. And let's look at the default parameter set. So I'll put 1 in here. For each system, so let's get rid of just the Kepler 10b filter. Each system that has 3 stars. And then using these arrows at the top, you can actually sort. So I'm going to sort by decreasing orbital period. And let's say that we're agnostic, indifferent to the number of planets. So you can click the X and actually just get rid of that. So now we've made a custom version of the planetary systems table here. You can see that there are 53 different planets, because we filtered on default parameter set, that are in systems with 3 stars, and that the longest orbital period is over 16,000 days. Wow, that's crazy. So you can also create a user account and save customized versions of any of our planet data tables for future use. You can see up here in the menu bar that I'm logged in as myself, Chenderson. And if you hover over user preferences, you could save this specific version of the table, and you can load any versions that you've previously created. And these persist when you log out, log back in, so you don't have to worry about losing any data. This should hopefully provide help in accessing kind of quick versions or views of the table with specific filters that you might use frequently. So another way to access data in this planetary systems table is to use the table access protocol, or TAP, and to identify the column names for the database names for specific parameter columns. Go to View Documentation, and then View Data Column Definitions here. And this documentation page provides the mapping between the column name for the TAP query that you would need and the label and description that you would see in the interactive version of the table we were just looking at. And this also identifies which columns are present in each of our 2 primary data tables. So you can see in PS table, this corresponds to the planetary systems table that we're looking at. PSCP refers to planetary systems composite pars. That's another new table that we'll talk about a little bit later. From this documentation page, you can also access the documentation page for our TAP service. And this TAP service is what allows you to filter and download your desired version of the planet data table by constructing a URL in a browser tab, or even embedding the relevant query in your own piece of software. So feel free to check out all of these documentation pages. And I'll note at the end how to contact us if you have any questions. So from the planetary systems table, let's go back to this first browser tab. You can also access our new system overview pages by clicking on the blue hyperlink for given planet name. So let's go check out our new system overview page for a specific system. I'm going to pick the Kepler 10 system again for continuity's sake. So this opens up a new browser tab. And whereas we used to have a variety of different overview pages for different types of objects, different types of data, we've consolidated all of these archive products into one page. So here we have our new system overview page for Kepler 10. At the top, we have a graphical description of the planetary system generated using actual physical data. And below this, there's a schematic of the orbital architecture of the system. So here we can see that the name of the system is Kepler 10. It has 1 star, hosts both of the planets. Its name is Kepler 10. And each of the 2 planets are confirmed planets. That's what the purple color denotes. So Kepler 10b and Kepler 10c. And in this top pane, we can also see the discovery information for each of the planets in the system. So as we scroll down, we can see that different sections of the overview page contain parameter data for different objects in the system. So I'm going to go ahead and click on the Kepler 10b planet parameters. You can click anywhere along here. And now you can see that there's a different column for each of the solutions that's listed in the planetary systems table. And one neat feature is that if you click on the icon to the right of a manuscript reference, it's going to highlight the corresponding stellar parameter solution. So this is an easy way to identify which solutions are tied to each other and thus physically consistent. If we keep scrolling down, we get to the ancillary information section. And this section provides access to the different Kepler project data products, including data validation reports at the top here, and then KOI solutions down here. Below that, we have our nearby data section. And this lists all known objects within 30 arc seconds of the planet host star, as well as any data files in our inventory for this system, such as Kepler light curves. You can see that right here. Finally, at the bottom, we have our bibliography section, and this gives a list replete with links to ADS for any manuscript that discusses the given system. So let's go back to the first tab and go back to the home page. I'll mention that although the planetary systems table is our new workhorse table for planet data, there are several other planet data tables that we host, and that you can see down in this section, the work with data section. And this includes tables that are tailored to planets discovered using the microlensing technique down here at the bottom, the direct imaging technique, and also tables containing transmission or emission spectroscopy data. There is also, as I've alluded to before, our planetary systems composite data table. And we'll take a look at that now. So I'm going to go ahead and click on the link here. This will take us directly to another interactive table, just as we were looking at with planetary systems, but it'll look a little bit different. So similar to the retiring confirmed planets table, this planetary systems composite table has exactly one row for confirmed planets. So you can see now there's 4,324 instead of the nearly 30,000 that we'd seen in the planetary systems table. The big difference between this table and the planetary systems table is that here, the data for a given planet are not necessarily drawn from a single data source. We have a red banner to kind of draw your attention to that as a user in case you forget this philosophical difference between the tables. So while this means that the data may not be physically consistent, this table does pull from our full data inventory to fill in gaps in the planetary systems table. So this makes it far more complete and arguably useful for getting a sense of overarching demographic distributions. So and as an example, let's go ahead and clear all of the selected columns. So I'm going to clear all and add a subset of columns just by checking. So we added planet name. Let's go ahead and add, let's see, what do we want? Let's do planet radius in Earth radii along with its reference column. Let's do the same for planet density. Let's also add eccentricity. And let's finally add insolation flux. And so you click update to implement the changes. And then let's take a look specifically at Kepler 10b again. And I'll expand some of these columns so that you can see them. But basically, one of the things that we see here is that the planet radius and planet density values are taken from the same reference, whereas the insolation flux and eccentricity values are taken from two different other references. I'll note as well that this table is one of the few places in the archive where we perform calculations. So if we clear the filter in planet name on Kepler 10b, we can see that the reference for planet radius is listed as calculated value for a lot of planets. And so here, for this specific parameter, we use the Chen and Kipping 2017 mass radius relation. I'll note that we also perform calculations for a bunch of other parameters as well. You can see planet density is one of those. And if you have any interest in what that set is, you can click on calculated value. It'll take you to a documentation page. And I'll note that we plan to expand the set of parameters for which we include calculations in this table on the next year timescale or so. So stay tuned on that front. So let's go back to our front page and switching gears. We've been focusing on data and our new planet tables. but I want to show you the different types of figures that we make available. So I'm clicking on this plots button here. So this page gives you access to downloadable versions of each of our pre-generated plots that are updated for each of our data releases. So these are designed to be talk ready, so you can insert them into your slides and sleep soundly knowing that you have the most current tabulation of exoplanet data. We also provide colorblind friendly versions of each of these plots. And for several of them, we additionally include a link to an interactive plotting environment generated by the Filtergraph team at Vanderbilt. And I can go into that in a little bit more detail during the Q&A if we want. So going back to our front page, one more time, I'll mention that we also host contributed data sets from a variety of space and ground-based missions. So if I hover over the data tab here, you can see that this kind of second column of links allows you to peruse all of the Kepler mission products as well as photometric time series from other surveys, such as KILT over here in the third column, and UCURT, dedicated microlensing survey of the galactic bulge in the last column here. We also have FDL PyAtmos atmospheric data, model atmospheres for different planets, as well as data from the CubeSat Asteria mission, among others. In addition to data, we offer the ability for you to use any of a variety of data analysis tools. And those are under the section Tools and Services down here. So some examples include our periodogram tool, the ExoFast software suite developed by Jason Eastman. And this is for jointly fitting transit and radial velocity data. Our transit and ephemeris service right here. And this is to help you plan your next observing run or to utilize some extra time you might have at the end of a given night. So we also host data from the Transiting Exoplanet Survey Satellite, or TESS, and you can view a table of the current TESS objects of interest, or TOIs, by clicking here up where it says TESS Project Candidates. This will take you to another interactive table, and this one contains data delivered by the TESS project and is updated daily. So if we want to go ahead and filter on a specific TOI, I'm picking TOI 101, and you click on the hyperlink, this directs you to our ExoFOP test page for the given object. ExoFOP stands for Exoplanet Follow-Up Observing Program, and is designed to be a sandbox for the community to support follow-up of TOIs. So here there are tabular data, time series data, and image data, and users are able to contribute their own data through this service. So the left-hand side of a given ExoFOP test page lets you access the different types of data that are available for a given object, and also explore the relevant inventory that's hosted by the NASA Exoplanet Archive, which we've been talking about today, as well as other online data repositories, such as URSA, SIMBAD, MAST, and the Keck Observatory Archive. On the ExoFOP test homepage, you can access by clicking Tests up here. You can also view different observation summary tables listed over here. And in this middle box, you can search for any object group by a data tag. I'll close by taking us back to the archive homepage and noting that we have a bountiful reservoir of documentation pages. These are to help you as you explore our data tools and services. So one way to access those documentation pages is this purple button down here. We also have a social media presence, so we encourage you to follow us, get news on latest planets, updates, especially as we're going through this revamp process, changes that we're making to our data tools and services. You can follow us through there. And last but not least, we have a help desk through which you can contact us. So literally the contact us button down here. And you can reach out with any questions, clarifications, suggestions that you might have. Why is my favorite planet not in here? Why is this other object in here? And I'm going to go ahead and include the link for this contact us form in the Zoom chat, just in case we don't get to all questions during the Q&A. You can use that form, reach out to us, something that you saw during this presentation or something that has been burning a hole in your brain for a while. So I'll take us back to the front page. I'll say thanks for watching and have fun delving into everything we know as humans about confirmed exoplanets so far. And if there are no questions, I'm also happy to kind of highlight some of the tools that I didn't get a chance to talk about.
All right, thank you so much for all that information. If anyone does have any questions, feel free to unmute yourself and talk out loud, or if you don't feel comfortable, you can enter them in the chat and we can do it that way. Just a reminder, we will ends at abruptly 1:59. So ask away.
Stunned silence, taking it all in. Well, I'll go ahead while people are brainstorming questions and give everybody kind of an additional tour of some of the cool stuff that we're rolling out as part of this revamp. So I've clicked back to the Planetary System page. It's the Planetary Systems table. What I'm going to do now is take you to a couple of specific system overview pages that highlight some cool things. So if I type in EXO2, we can take a look at the EXO2 system overview page. This is a system with multiple stars, each of which hosts multiple planets. And so you can see that up here. And this changes, for example, how the architecture of the system looks. Another interesting system is the Gj15 system. So if we go to that link, this is one that has multiple stars and multiple planets, but not necessarily multiple planet hosting stars. One of the differences here is that you can see that one of the putative planets has been marked as controversial by us. And so that changes the color coding of the object on the page, including in the architecture schematic, the discovery panel, and the actual planet parameters system, or the section down there. Another system to take a look at is Gj229. Again, a system with multiple planets and multiple stars. In the graphical representation we're about to see at the top, though, there's actually no physical information for the companion star, the non-planet hosting star. So as we have given it a name, from the literature, it has an alias. The lack of physical parameters makes it look gray. So that's not an accident or anything. That's to indicate, hey, we could learn more about this star. We don't actually have very much information. Another one, Gj667. This is a system that is pretty wild. Wait for it to go ahead and load. While that one's loading, let's preemptively load one more. So I'll load Kelt9 as well. So 667 is this system.
Question.
Oh, do we have questions?
We do, just one.
Okay, I'll go ahead and pause this.
Do you want to read it or you want me to read it?
Oh, I can go ahead and read it. Thank you.
Okay.
Are ExoFOP logins required only for ExoFOP contributors? Yeah, so the perusal that I was doing just now, I was not logged in to ExoFOP and was able to look. Oh, it looks like David CRD is answering it as well. Logins are open to everyone. Logins are only needed to upload. Yeah, exactly. So you can view and download without a login. But if you want to contribute data, you would need to create a user account and go that avenue. Good question. So I'll continue our tour of features on the system overview pages. So no, it's all right, David, you're okay. Gj667, 3 stars, 5 planets, 3 of them are marked as controversial. All of the confirmed or controversial planets are orbiting one of the stars. Another one of the stars has no physical information, this companion star from the WDS catalog. And we can also take a look at Kelt9. I really, really love this one because it visually emphasizes how we're pulling data from the literature to generate the graphical overview at the top. So the host star is an extremely hot star, over 10,000 Kelvin. And so the color coding maps onto that accordingly. There's one more system that'll be fun to look at. It doesn't actually contain any confirmed planets, so you can't access it from the Planetary Systems table right now. But we're going to the KOI5 system. So this has 2, I'll say objects in air quotes, one of which is a candidate planet. That's what blue with a question mark means. And the other of which is a false positive. So that's what the brown with an X means. So I just go through that to highlight all of the different ways in which we have encoded information into various aspects of the system overview pages. Hopefully those will be used very heavily, especially as they've kind of been aesthetically updated from our current set of overview pages. So I see another question in the chat. Michael is asking, what constitutes being marked as controversial? That's a great question. Basically, the way it works is if a paper comes along and says, hey, we found a planet, here its data, here's data for its host star, et cetera, and that paper has gone through a referee process and enters the refereed literature as a manuscript, we don't do any additional scientific litigation. What is in the refereed literature is our kind of fundamental scientific backbone. And so if a planet comes out, planet discovery paper comes out, we are going to ingest it as such. However, there are instances in which perhaps a follow-up paper, also again, necessarily in the refereed literature, comes along and adds new data, applies a new analysis technique, or for some other reason says, hey, this first group of authors found a signal and they ascribed it to a definite planetary object. But we have these reasons to believe or to think that the signal can be ascribed to some other astrophysical source, or perhaps even an error in the data reductions or whatnot. If the language is incredibly strong, that would be enough to demote the planet. But there are many instances in which it's kind of gray, or the nature of the system is unknown. So in those cases, rather than totally mark the planet as refuted, we'll just put up kind of a warning flag and say that it's controversial. It's a good question. So while I'm waiting for other questions, I'll go back to the home page. And I am a microlensing scientist, so I'll highlight one of our kind of what I call specialty planet data tables, or data tables tailored to a specific detection technique. So specifically going to pick the microlensing table, but we also have a direct imaging table as well. So one of the things that these kinds of tables do is they include some basic planet and stellar parameters, but they also include data tailored to that technique. So here, if we scroll over, we see we have a lot of microlensing specific parameters: the time of lens source minimum separation, the Einstein crossing time, the normalized source angular radius. And so one thing that you could do in this specific table is you say, well, I want to know every planet with a mass ratio smaller than 10 to the minus 4, so planet mass divided by host star mass, that's more distant than 2,000 parsecs. And maybe I want only the OGLE survey discovered planets. Well, okay, now we've mixed and matched criteria for filtering based on data that we could find in planetary systems, such as the distance to the system, and data that you can only find currently in this specific table, namely the mass ratio. And we see that, hey, that's kind of wild. There are 6 different planets that are more distant than 2 kiloparsecs from the solar circle, and that have a mass ratio smaller than 1 times 10 to the minus 4. All right, we're nearing the end. I don't see any other questions. I'll see if I can fit in just one quick side quest into our plotting mechanisms. I just really want to emphasize our partnership with the Filtergraph team at Vanderbilt. So I've clicked on the Filtergraph link for a specific plot, our mass period plot, and hopefully it loads here quickly. Basically, this is a new way of visualizing data that we have here at the archive. And we have predefined links. All right, that one's taking a while to load. Let's try this one. And these links allow you to go into the Filtergraph environment and actually save versions of these plots or modify them. And another cool thing is you can hover over data points here. Let's see if I can get one. And it actually shows you basic information about that data point. And then you can use this URL to dynamically reload previous versions of a given plot that you have created in the Filtergraph environment. So thanks, Filtergraph and Vanderbilt, for doing that. We really dig this. It's 10:59, so I'll say thanks, everybody, and feel free to reach out to us.
Thank you, everyone.